Welcome back to another exciting round of physics. Today we are going to revise Form 4, Archimedes Principle, and I call it Part 1 because there are 3 parts to Archimedes Principle in my series here. And let's take a look at some of the things that you must understand about physics. First of all, you must tell yourself, you can master Archimedes Principle. You can understand it. It is something that is very simple. So just follow me. Now, at the end of this lesson, there are 2 things that you will be able to master. That is, number 1, you will understand the principle of Archimedes, what it is all about. And the second thing that you will understand and are able to do is to solve calculation problems involving Archimedes' principle. A little reminder here to all of you. If you want to understand something in physics, remember, memory is not the method. You must do it, practice it, rehearse it, answer questions, try it out again and again. So that will be the key to understanding physics. So we are going to do that today. I will just throw a question to you first before I explain Archimedes' principle. For example, here we have a question. The weight of X in air is 8 newtons. And in diagram 7, you find that the weight of this object X, when it is immersed completely in water, it is 6.3 newtons. That is the reading on the spring balance. So the question asked is, what is the buoyant force acting on the object X? Now, to understand this, there is a little activity that I would like to engage you on. Let us now take a look at the experiment. Now, here I have a cartoon version of the drawing of the experiment. Okay, let us do the experiment. Be prepared to get wet. Now, this is a very simple experiment. Now I have an object. Let's say I call it object Z. And Z, I am taking its weight in air. All right, let's have a go. Okay. 10.0 newtons. So that is the weight of Z in air. The second part of the experiment, I'm going to immerse it in the water. Be careful. Don't break the fish tank. All right. Very good. So now Z is completely immersed in the water. And it is not blocked by anything. It does not touch the base of the fish tank. All right. I'll take its weight now. Good. It's 8.6 newtons. All right. So now I'm going to record the results and we are going to take the discussion from here. All right, let's go into the discussion now to understand what Archimedes' principle is all about. Just now I mentioned that Z here, this is the object Z, and it gives us the reading of 10.0 newtons in air. So I will mark here 10.0 newtons in air. And remember just now I took it and immersed it completely into the water. So what did I do? I immersed it into the water. Right? That's what we got just now, isn't it? And what was the reading on the spring balance then? There was a different value. Alright? And I will mark it in red color. So we have Z there, and the reading here is 8.6 newtons. We have not changed the object. It is still Z, but the reading now in water, and this is the water that we had just now, the reading of the spring balance in the water is 8.6 newtons. So now what has happened actually? Now this is the crux of the point. This is the crux of the whole concept. There is a force that is pushing Z up. There's a force pushing it up. Can you feel it? Now, and the force is pushing, there is a force pushing up Z until its reading is only 8.6 newtons. So we ask ourselves, what is the value of the force that is pushing Z up? Now this is simple arithmetic, isn't it? All of us will know that there is a force pushing it up, and this value must be the difference between 10 newtons and 8.6 newtons. And all of us can tell, even without using our paper and pen. And we know that the value is 1.4 newtons. And what do we call this 1.4 newtons? That is the buoyant force. The buoyant force is 1.4 newtons. Alright? So now let us summarize the first part of the lesson, that is, what is Archimedes' principle? Now, Archimedes' principle, if I may just summarize it with just a very small equation, it says this. The buoyant force acting on an object, whether it is completely immersed in a liquid or partially immersed in a liquid, this buoyant force, it is equal to the weight of the liquid displaced. So in this case, it is water, so I'll use water. So buoyant force is equal to the weight of the water displaced. Weight of water displaced. Alright? And in this case, we have done the calculations. It is 1.4 newtons. Now, be very careful. The weight of water displaced, that is something that is very important. It is not the weight of the object. It is the weight of the water displaced, and that is equal to the buoyant force. You will notice that I did not even write down another equation for you to calculate, because you will tend to memorize equations. All you have to do is to understand the concept. Let us just do one example. I think we have time only for one example. Come back to the first example, question 7 that I mentioned. The weight of X in air is 8 newtons. Alright? And in diagram 7, the weight of X in water is 6.3 newtons. So again, there must be a certain force that is pushing X upwards. Okay, everybody follow me. Okay, so there is a force that is pushing X up. And how much is this value? In air, it was 8 newtons. And now it is 6.3 newtons. So again, you would be able to tell me, I'm very sure, that the upthrust here acting, it must be 8 newtons minus 6.3, and this gives us the, I call it, the buoyant force, FB, alright. The buoyant force acting upwards, it must be equals to 1.7 newtons. Because originally in air, it is 8 newtons. Alright, so now it is 6.3 newtons on the spring balance. So upthrust must be 1.7 newtons. Okay, so once you understand this, you will know that the buoyant force is equal to the weight of the liquid displaced. Alright, so that summarizes what Archimedes' principle is all about. And this is a very simple question that you can answer. I think we may have time for a very quick one because it's so simple. Let's do one more. Question 8. The weight of P in air is 4 newtons. In diagram 8, you are told that the buoyant force acting on P is 0.7 newtons. So what is the reading on the spring balance now? Now the weight of P in air is 4 newtons. Now there is an upward buoyant force pushing it up 0.7 newtons. So it's so simple. So what is the spring balance reading? Just with the snap of your finger, you can tell me that it must be 3.3 newtons, right? 3.3 3 newtons the reading there, because the buoyant force acting upwards is 0.7 newtons. And its original weight in air, it was 4 newtons. So I'm very sure all of you would have understood it, you have caught it. Alright, so it's something very, very simple. And I'm sure as you look at some more problems and solve it, you would have mastered it. Okay, so you understand the meaning of Archimedes' principle, and you have solved a few numerical problems involving this Archimedes principle. Alright, so with that, I would like to say thank you very much, and may God bless you.